This is a solution video for the fall 2023 final exam for Calculus 1 at Oklahoma State University. So this says I want to consider this piecewise defined function, and then it's asking me questions about whether f is continuous at 2, the limit as x approaches 2 from the left of f of x, is that equal to f of 2? Is it differentiable? And does the two-sided limit exist? So one thing we might do is try to just sort of think about what a graph of this function might look like. So I know that at 2, the function is defined to be 10. So that point can be plotted there. I know that for x less than 2, it will be given by this function, x to the fourth minus 6. And so if I plug 2 into that, I'll have 2 to the fourth minus 6, which would be 16 minus 6, which is 10. So as x is approaching 2 from the left, that y value is going up to 10. And then for this piece, as x is greater than 2, this is the function that is defined by that. So if I plug 2 into that, I'll have 4 times 2 cubed minus 16 times 2. And that gives me 0. So that function is going to 0. I'm not sure if it's increasing or decreasing, but whatever it's doing, as I come in from the right-hand side towards 2, my y value is approaching 0. Okay, so I think that gives us enough to answer these questions. So the first one is the function f continuous at 2? The answer to that is no. There is a jump discontinuity. The next one says the limit as x approaches 2 from the left of f of x. So I'm looking at as x approaches 2 from the left, what y value is that approaching? Is that approaching the function value? And that one is true because it's approaching 10 and the function value at 2 is 10. The next one asks if f is differentiable at 2. So it is not differentiable because it needs to be continuous to be differentiable. And then the next one is that the two-sided limit as x approaches 2 exists, and that is also not true because there's a jump discontinuity. So the only one that's true is 2, so the correct answer is A. For the next one, I need to think about the value of f of 2, f prime of 2, and f double prime of 2. So for f of 2, I'm going to be, let's see, am I given the function f? I'm given the graph of a function f, so this is f. At 2, the y value is 0, so f of 2 is 0. What about f prime of 2? So I'll be looking at the slope of f when x equal 2, and that slope is positive. I could maybe go in more detail and compute what the value of that slope is, but I think for now I'll just say that it's positive, and then if I need to be more specific, I'll come back and look at that. Let's look at f double prime. F double prime of 2, I'm looking at the concavity. So since my function is concave down, I can say that f double prime of 2 is negative. And so that information is enough for me to order the thing. So it'll be f double prime of 2 will be the smallest, less than f of 2, which is less than f prime of 2. So the correct answer is D. This one says Casey is going for a run before school. She starts her run from home. The function y equals v of t expresses the relationship between Casey's velocity as she runs and the number of minutes elapsed. What quantity does the following right endpoint Riemann sum approximate? Okay, so I know that it's a Riemann sum. I know it's a right endpoint. It's written this way with the sigma notation. I think it might be helpful if we just kind of wrote out some of the terms just to see what this is doing. So when k equals 1, if I plug 1 in, I'll get v of 1 plus 0.5, so v of 1.5 times 0.5, plus when k equals 2, I'll get v of 2 times 0.5, plus, and I keep going, and the very last one will be v of, when I plug in 6, I'll get 1 plus 0.5 times 6, so 1 plus 3, so that'll be v of 4 times 0.5. Okay, and then if I think about what this means, each of these is going to be a distance, or sorry, it would be a velocity times a amount of time. So this would be a distance. So each of these are distances, like the amount of distance traveled. And if I think about what they would look like in terms of like rectangles, I have like 1.5, 2, 2.5, and it stops at 4, and so these are right endpoints. So the right-hand side is determining the height, and so maybe we have some sort of a graph here. So the right-hand side is determining the height, and then the last rectangle will be here, and it will go from 1. Okay, so each of these guys is a distance. So we're adding up the total distances from time 1 to time 4. So this is, the correct answer is B, the change in Casey's distance away from home over the interval of time from t equal 1 to t equal 4. Next, it says, suppose f prime is greater than 0 in the interval 2 to 5. So if I were to kind of graph this function, it's just something increasing. I don't know exactly what it's doing, but I know it's increasing. And it says the value of the definite integral is less than the numerical value. So I want to find something that's greater. Okay, so the first one says 3 times f of 4. So f of 4 would be, I don't know, some value here. And then 3 is this distance between 2 and 5. So 3 times f of 4 would be the value of this rectangle, which, well, depending on how steep my function is, it might be less than, it might be greater than. It's not clear. It doesn't strictly have to be less than. So we'll throw that one out. So next, we have these different, looks like Riemann sums. So one thing you might notice is that some of them contain this limit here as the number of rectangles goes to infinity. And so those are going to actually end up being definite integrals. So these will be equivalent to the integral from 2 to 5 of f of x dx, because you're letting the number of rectangles go to infinity. Now this one, these two are a set number of rectangles. So we'll throw out b and d. These two are like a set number of rectangles in rectangles. And so basically, since my function is increasing, I want to pick the one that is an overestimate. So I want to pick the one that is a right-hand sum. So of these two, I need to pick the right-hand sum. So how do I decide which one is the right-hand sum? Well, let's write out a few terms of this and see what's happening. So when k equals 1 here, I'll have f of 2 plus 3 over n times 3 over n plus dot, dot, dot. Okay, so that's saying that I'm scooching over from 2 to here, and my right-hand side is determining my height. So this one is a right-hand sum, so the correct answer is C. Why is it not E? Let's plug in 1 here and see what we get. We'll get f of 2 plus, and then that's going to be 0. So it's going to be just f of 2 times 3 over n. So that is a left-hand sum. It's using the left side to determine the height of the function. So the integral will be less than this right-hand sum. So the correct answer is C. Okay, for the next one, I have the expressions that represent numerical values. Which expression represents the largest one? Okay, so first of all, what graph are we given? Are we given f the graph of a function f. So this is f, not f prime, which represents the largest numerical value. So f prime of 3 pi over 2. So let's go to 3 pi over 2, go up here. The derivative of that is 0. The slope of the tangent line is 0 there. What about this? This is an average rate of change from pi to 2 pi. So if I draw a secant line there, the slope of that secant line is also 0. F double prime of 3 pi over 2. So at 3 pi over 2, f is concave down, so this is negative. And then this one is an integral from pi to 2 pi of f of x dx. That would be this area. Since that area is above the x-axis, this is going to be some positive value. So clearly D is the biggest one of all.